This search box is updating from the server as I type. No page reload, no client-side state store, and no JavaScript that I wrote for the interaction. The browser sends a request, the server sends back a finished HTML fragment, and one tiny library swaps that fragment into the page. Now compare that with the default single-page app route. A component owns state. An event handler calls an API. The API returns JSON. Client code turns that data back into UI. Then the framework reconciles the new UI with the old one. That architecture is powerful, but for a search result, a form, or a dashboard row, it can be a lot of machinery. HTMX asks a more useful question than "Is React dead?" It asks, what if the server could send the interface itself? Once that clicks, HTMX stops looking like a bag of magic attributes. It becomes a very small hypermedia client with one repeatable loop: request, HTML response, swap. The persistent object in this story is an HTML fragment. At first it lives on the server as a template. A user action turns it into an HTTP response. HTMX carries it across the network, finds a target in the current document, and replaces only that part of the DOM. The server remains the source of application state. The browser owns the interaction that is happening right now. Here is the smallest useful example. An input has hx_get, pointing at /search. hx_trigger says to react to changed input after a short delay. hx_target points at the results list. As the user types, HTMX sends the input value with the request. The server filters its records and returns list items, not a JSON object. HTMX drops those list items into the target. 4 attributes describe almost the whole transaction. The verb says what request to make. The trigger says when to make it. The target says where the answer belongs. And the swap says how the new fragment should enter. Replace the inside. Replace the whole element. Append, prepend, or delete. That is more important than the syntax. Ordinary HTML gives request power mostly to links and forms. HTMX generalizes that power. A button can post. A row can delete itself. A panel can refresh on a timer. An input can debounce requests while someone types. The element declares its behavior close to the markup you are already reading. This is called locality of behavior. It does not mean every implementation detail belongs in line. The database query, authorization, and template logic still live on the server. The markup only exposes the interaction contract. This event makes this request and places the response here. You can understand the click without hunting through a component, a hook, an API client, a state slice, and a route handler. Now follow the fragment through the real loop. First, the browser dispatches an input event. HTMX reads the attributes and builds an HTTP request. The server validates the request, queries its own state, and renders the next valid UI. The response crosses back as HTML. HTMX selects the target, applies the chosen swap, and settles the new DOM. CSS can animate the transition, and HTMX emits lifecycle events if a small amount of custom behavior is still needed. The same loop scales beyond one target. In HTMX2, out-of-band swaps let one response update a primary region and additional elements identified elsewhere in the document. A cart action can replace the line item and update the cart count in one round trip. Boosted links and forms can keep normal navigation semantics while replacing page content in the background and participating in browser history. Wound. That last detail matters, because a fast-feeling page is not enough. Navigation still has to survive refreshes, copied links, and the back button. HTMX can push request URLs into browser history and restore prior content, while the server remains able to answer a direct visit. This is progressive enhancement at the architectural level. The URL and server response stay meaningful even when the interaction becomes smoother. You also do not have to turn the whole site into an HTMX application. A single form can opt in. One expensive table can gain live filtering. A normal link can be boosted while everything around it keeps ordinary browser behavior. The adoption unit is the element or page, not an all-or-nothing rewrite. That makes HTMX useful as a pressure release valve when one workflow is drowning in client synchronization code. HTMX4 makes that routing model more explicit. The current public beta adds HX partial, so a server response can carry multiple fragments, each naming its own target and swap strategy. It also adds morphing swap styles that preserve more DOM state, and status-aware swap rules, so a validation response can target an error panel while a server failure performs no swap at all. Those features are promising, but beta matters. The HTMX site currently labels version 4 as under active development. Its migration guide documents changed defaults and removed behavior. If you are shipping production software today, choose the stable line unless a version 4 feature earns the migration risk. A new major version is not a reason to skip release notes. Let's prove the core idea without a framework. This tiny node server has two routes. The page route returns an input and an empty results list. The search route receives a query, filters 3 names, and returns only list items. There is no JSON serializer, no client model, and no code that rebuilds those rows in the browser. When the browser types ADA, the request is a normal get-to/search with the query value. Watch the response body. It is already the next interface, a list item containing Ada Lovelace. HTMX does not interpret business data. It puts finished hypermedia where the input told it to go. That distinction changes who owns complexity. In a typical SPA, the server and browser often maintain related models, and an API contract keeps them synchronized. In a hypermedia-driven application, the server can keep the authoritative model and emit the allowed next actions with the HTML. The client still has state, the focused input, an open menu, a playing video, but it does not need a second copy of every domain object. This is also why bundle size comparisons can mislead. 16 kilobytes is a useful fact about the stable HTMX line, but network weight is not the whole decision. Server latency, cache behavior, template cost, interaction density, team skills, testing, accessibility, and the number of states that must exist before a response all matter more than a single compressed number. The architecture wins only when its ownership model matches the product. There is real evidence that this can reduce code, but context is everything. In a published case study, Context is moved a content-focused application from React to Django templates and HTMX. They reported a 67% reduction in total lines of code, JavaScript dependencies falling from 255 to 9, and build time falling from 40 seconds to 5. That is one application shaped unusually well for hypermedia, not a universal benchmark. The useful lesson is not HTMX is always smaller. It is server-owned workflows can delete an entire synchronization layer. And this is where the React versus HTMX framing usually breaks. React is excellent when the browser is the application, a spreadsheet, a design canvas, a map with immediate manipulation, an offline first editor, or a screen with many interdependent widgets reacting before the network could answer. For those systems, client state is not accidental complexity. It is the product. HTMX is strongest when the server can answer each interaction with the next useful piece of UI, forms, search, CRUD screens, content, admin tools, account settings, commerce flows, and many dashboards. Network latency still matters. Server rendering still costs work. Long-lived client interactions may still need JavaScript. And you can combine approaches by placing an interactive island inside a broader hypermedia application. So use a simple decision rule. If the interaction can be modeled as the user acts, the server decides, and the server returns the next UI, start with HTMX. If the screen must react instantly to a rich graph of client-owned state, start with React or another client framework. If the page contains both, split the boundary instead of forcing one tool to own everything. The HTML fragment has now completed its journey. It began as a server template, crossed the network as the response, and became the next visible state of the page. That is HTMX in one sentence. The server sends UI, and the browser swaps it into place. HTMX4 adds better ways to route and morph those fragments, but the durable idea is older and simpler. You do not always need to ship data to a second application running inside the page. Sometimes the web page can be the application, and HTML can carry the next move.